in the particular case of a Moran process where we only have two types of individuals, like the hawk-dove game and various other games, then actually a lot of these things can be done analytically because we can essentially reduce the dimension of our problem. So if we assume before that we had a vector v, which was v1 and v2, but because we know that v1 plus v2 equals big N, we can essentially get rid of this from our notation and just consider little n. So the entire state of our, sorry, let me make sure you can actually see what's on my screen. The entire state of our system can be represented by a single number n. And so then all the possible states are either 0 individuals of the first type, 1 individual of the first type, 2 individuals of the first type, all the way up to n individuals of the first type. And what we have are these probabilities going back and forth between these single numbered states. And so we can make use of this because that means we can write down the probability Pij being the probability of going from I individuals of the first type to j individuals of the first type. We have a couple of things that we can immediately write down, which are that Pi to I plus 1 plus Pi to I minus 1, in other words, the probability of going up by a number of individuals of the first type or the probability of going down by the number of individuals of the first type. If you sum those two things, in other words, for the probability of there being some sort of change, it has to be less than or equal to 1. There's another chance, which is that when you're in state I, you stay in state I. And that's given by Pii is equal to 1 minus Pii I plus 1 minus Pii I minus 1. And the final thing we have is that P naught naught is equal to P n n and is equal to 1. In other words, that these states here are absorbing states. Once we have nothing but individuals of the first type or no individuals of the first type, our system does not change. And these probabilities are going to allow us to write down formula to answer our original question when we started the Moran process, which is we care about whether or not when we start somewhere in here, we finish in this state or in this state. And we can write down that probability explicitly. And we'll see how to do that now.